Circle all the exponential equations below. So in order for it to be an exponential equation, the variable has to be the exponent. So what type of function is this? Linear. This one is linear. I didn't tell you to tell me this, but I'm going over it. What is this one? Exponential. What is this one? Exponential. What is this one? Linear. You are expected to know these because this is what Unit 6 is all about. What's this one? Quadratic. What's the next one? Exponential. What's this one? Quadratic. What's the last one? Exponential. Okay, does everybody understand the difference between that? Okay, we're going to skip this part here. We'll probably come back to it later, but we're not going to do this part here today. All right, turn the page to where we are graphing. Okay, do you remember the transformations from quadratic functions? They're the exact same thing in exponential. Remember I told you if you didn't understand transformations, and some of you don't, then you're going to need to do this. Okay, so graphing exponentials, there are two basic types. There is a growth function. There is a decay function. If it's growing, it starts low and goes high. It can also grow negatively. So it will start high and go low, but it's going negatively. So it is growing negatively. Okay, if it's a decay function, it starts high and goes low, and then it can decay negatively also. Okay, so decay, we know 0 between that and that, yes? Okay, so let's come down here and look. So here you'll see this way, and then you'll see that way. So this is A is greater than 0, A is less than 0. So the reason it's it is decaying negatively or growing negatively is because A would be a negative, so it would make it be reflected, right? So you take it and you reflect it. It's still decaying here. It's just decaying negatively. Here it's still growing. It's just growing negatively down here. Yes, ma'am. Okay. So do you remember how we did the charts and everything for the quadratic? So this works the same. If I put -2, now for graphing, you can have decimals because we would like to have decimals, right? So put -2 in here and somebody tell me what I get. 0.25. And then if I put -1 in, so a half. And then anything to the 0 power is 1. 2 to the first is 2. 2 to the second is 4. 2 cubed is 8. The little spot in the middle is in case you want to show that you go 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, 2 to the second, 2 to the third, in case you want to see how you do it. Okay, does everybody understand how to plug and chug? Because we did that. Remember I told you in quadratics, if you can do it in quadratics, when we get to exponentials, it's going to be a little bit easier. Okay? Now, here, do I have to plug this in my calculator? What does this 3 do to the problem? What does it do to the graph? It stretches. It makes it bigger by 3. So this stretches by 3. So that means if I know 2 to the x is 0.25, without even doing a calculator, 3 times 0.25 is 0.75. This is the same problem as this. The only difference is multiply by 3. So 3 times 0.25 is 0.75, right? 3 times 0.5 is 1.5. 3 times 1 is 3. 3 times 2 is 6. 3 times 4 is 12. 3 times 8 is 24. Does everybody see that that 3 made those numbers bigger? You can actually see the stretch like we know it's doing. Can I do the same thing with this? Can I just multiply by 2? No, because my base changed. Does that make sense? So when your base changes, it creates a new function. Okay? Do you remember in quadratics, numbers had to change in different things? This one, as long as this base is the same, the parent function here is not going to be like y equals x squared. The parent function is going to be y equals b, and that b can be any number raised to the x. So this is the parent function that's been stretched by 3. Does that make sense? But this is a totally different parent function. Okay? All right. So what is 4 to the negative 2? Not negative. It should just be 0.0625, right? Yes? Is that what everybody got? Okay, then when you put negative 1 in, 0.25. And then when you put 0 in, it's 1, 4, 16, 64. Okay, does everybody understand how I got those magic numbers? All right, now if we go down here, we're going to graph negative 2.25. Caitlin, are you back with me? Can you see my screen now? Okay, awesome. So we're just going to plot those points. My pointer plotter don't want to work too well for some reason. And then 2, 4. And then 3, 8. Don't connect them yet. We're just plotting them. Okay, this got started small and then it got big quickly. It grew exponentially. Exponentials grow really quickly because it's the base times itself. So let's go back up here and talk a minute. We're going to make a table. Check. We're starting to graph, and we're going to plot points and connect them with a smooth curve. But graph the asymptote. What's an asymptote? Anybody know? So an asymptote is a line that the graph gets really close to, but it never touches. Like it could be as close to like that, but it's never going to touch. Okay? So the asymptote is the K, the one out here. If there's nothing there, the asymptote is going to be y equals, what do we use for nothing in math? 0. So when you have y equals a number, what type of line does that make? But what type of straight? Vertical or horizontal? Horizontal, right? We knew from the last unit x equaled, remember the axis of symmetry? So this is going to be y equals. So we're going to put a dashed line at 0. And this graph, see how it got really close? And it'll keep getting closer. It gets really close to that asymptote, but it never touches. And then it grows really quickly. Okay, everybody good there? So let's go back up here. What would the asymptote to this one be? What's the K? There's not one, so 0, right? So we go back. We're going to put boop, 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 and we're going to do our graph. We're going to have negative 2 at 0.75. As long as it's between 0 and 1, I'm not going to dock you. Like it doesn't have to be really high or really close. Does that make sense? If it's a decimal, you put it between 0 and 1. And then at 1, negative 1, it's at 1.5. And then at 0, it's at 3. And then at 1, it's at 6. And then 2 is 12. I can't graph 12 on here, and that's okay. You don't have to graph all of them. They're just a guide to show me to keep going up, up, up. We're going to do that in a minute. We're doing the graphs. I'm doing it one step at a time to make sure you understand each piece. Does that make sense? We're going to finish it. All right, everybody good with me on graphing? You can't do 212, so you just keep going up. You can't graph everything in there. What's the asymptote here? 0, because there's no K. So we're going to go over here. We're going to do a dotted line at y equals 0. And then at negative 2, it's going to be right here. Now my graph will never cross that dotted line. Does everybody understand that it's going to get really close, but it will not cross it? At negative 1, a little bit higher. 0, 1, 2, 4, and I can't do 16 on this graph. Okay, let me ask you a question. 2 is at 16, so should it cross over 2 before I go off of this graph? No, because there's not a 16 here. 2, then 2 is at 16. So could I take this and go like this? Way over here. No, it should never cross the 2 line because I don't have a value for it. I will check you on that. All right. What is the x-intercept in this graph? Is where the graph crosses the x-axis. It doesn't. So there's not 0, none. Remember, 0 is a number in math. Okay? What is the y-intercept here? 0, 1. Very good. What is the x-intercept here? None. It does not cross because the asymptote's there. What is the y-intercept? 0, 3. What is the x-intercept here? 9. And the y-intercept? 0, 1. Okay. So you should be able to do that. Everybody good with just graphing? Yes. Yes, we're fixing to move on. Does everybody just follow with me? Everybody good with this one? All right, turn the page. The translations, okay? So the asymptote is a line that the graph approaches but never touches. Now when you get to Algebra 2 and you are doing rational functions, sometimes in a rational function, when you have a cubic, it will go through an asymptote, and we don't know why. But in this class, your graph will never touch that asymptote. Okay? Everybody good? All right. The equation, this should have the, for some reason the T didn't print. F of x equals a, b, x minus h plus k. Does anybody recognize those letters? What does a do? Stretch or compress. What does KH do? Left or right. What does K do? Up or down. Same thing here. What do we know about H? It always travels opposite. Same thing here. H tells us the horizontal movement. If H is positive, I'm going to move to the left. Oh, look at you. You already knew this. If H is negative, move right. Any questions at home, guys? Okay, if A is less than 0, we know it is going to reflect because that is negative, right? So that tells me my reflection. If A is greater than 1, it is a greater than 1. Stretch. So if A is greater than 1, it's a stretch. If it's between 0 and 1, it is a compression. So the same thing. You can love math because it kept these numbers and letters the same, yes? So if you learn this in the quadratic unit, all you have to do is learn the standard form. This is the standard form right here of an exponential function. So you have to know this, okay? B tells me whether it is a growth or a decay. We learned that yesterday. Okay, if K is positive, it's going to move up. If K is negative, it's going to move down. All right, everybody good? All righty, let's look at this first one. All right, so this is the parent function with the base 2. So what type of function is this? Growth or decay? It is a growth. All right, so the thing in black is without any transformations, okay? So if I subtract 2 from x, what does that mean I'm going to do? X minus 2. Let's look back at her. Look, what does the h do? Okay, so it's negative 2, so it comes out opposite, so it's going to go right 2. Does everybody understand? That's x minus h, so that's the h, so it comes out opposite. You're going to go right 2. All right, so if I pick up this right here, if I pick up this point here and I go right 2, 1, 2, it's going to be right there now. Does everybody see that?